Students, in this chapter, Structure of Atom, we are going to study about electron, proton and neutron, their discovery, and about different atom models, Thomson, Rutherford and Bohr atom models, about the quantum mechanical model of atom, nature of the electromagnetic radiation, and also the Planck quantum theory. This is an important one. Nature of the electromagnetic radiation and about the Planck's quantum theory. They explain the photoelectric effect and atomic spectra, state de Broglie equation, and also what Heisenberg uncertainty principle, Aufbau principle, Pauli exclusion principle, and also Hund's rule of maximum multiplicity. These are some of the important points that we will study in this chapter. And also we will study to write the electronic configuration of atoms. This is the main outline of what we are going to study in the chapter Structure of Atom. Let's discuss the introduction part of the chapter. We know that atom is derived from the Greek word atomio, that means what? Indivisible or non-divisible. Meaning of atomio is indivisible or non-divisible. John Dalton was the first scientist in 1808. He said about Dalton's atomic theory. That means atom is a ultimate particle of matter. That is, when we divide matter, we will reach a state when it cannot be further divided. And that state, John Dalton called it as what? Atom. It is the ultimate particle of matter. We already know that there are subatomic particles also that were discovered later, that they are electron, proton and neutron. Discovery of electron was done in 1830 by Michael Faraday. What he did? He studied the electrical discharge in partially evacuated tubes. Electrical discharge in partially evacuated tube. And it is known as cathode ray discharge tubes. Okay. And these negatively charged particles are called as electrons. Also, the charge to mass ratio of an electron. Charge to mass, that is E by M ratio. E by M ratio of an electron was discovered by J.J. Thomson. And the value of E by M, that is charge of electron to the mass of electron, the ratio of the charge and the mass was found to be 1.758820 into 10 power 11 coulomb per kilogram. This is the mass to charge ratio of an electron. Later, charge of the electron was discovered by R.A. Mulliken by his Mulliken oil drop experiment. And he discovered the charge as minus 1.6 into 10 power minus 19 coulomb. Okay, we already found the value of E by electron charge to mass ratio, and also now we found out what the charge of the electron. So we can easily find the mass of the electron, isn't it? So mass of the electron was calculated as 9.1094 into 10 power minus 31 kilogram. That is, mass of an electron is 9.1 into 10 power minus 31 kilogram. Okay, from the charge to mass ratio and also the charge of the electron, we calculated what? The mass of an electron. Remember, the mass of the electron is 9.1 into 10 power minus 31 kilogram. Okay. Next is the discovery of proton and neutron. Okay. Electrical discharge through modified cathode ray tube. This was the experiment for the discovery of particles with positive charge known as what? Canal rays. Okay. The smallest and the lightest positive ion that is obtained from hydrogen is what? Proton. Proton is an isotope of hydrogen. It is the smallest and lightest positive ion obtained from hydrogen is what? Proton. Chadwick in 1932, a scientist Chadwick in 1932, he discovered the electrically neutral particle called what? Neutron. Chadwick found in 1932 the subatomic particle called neutron. How he did? He did an experiment by bombarding thin sheet of beryllium by alpha particles. By bombarding thin sheet of beryllium by alpha particle. Okay, these are just an introduction about the discovery of different subatomic particles and also the experiments. There is no need to study the experiment in detail according to the new syllabus. Okay, this is the properties of, the table represents the properties of fundamental particles. What are the fundamental particles? Electron, proton and neutron. The symbol of electron is E, isn't it? The charge is what? Minus 1.602176 into 10 power minus 19. Remember the watt power value. Okay, 10 power minus 19. Similarly, so we will calculate the relative charge as minus 1. Also, the mass of electron is what we have already studied. It is 9.109 into 10 power minus 31 kilogram. Mass per, in atomic mass unit, the mass is what? 0.00054. Okay. For a proton, what is the charge? It is plus 1.602176 into 10 power minus 19 and the relative charge is plus 1. Okay, plus 1. Mass per kilogram is what? 1.672 into 10 power minus 27. And for a neutron, we know that it is, the charge for a neutron is what? 0. But the mass, it has mass. Neutron does not have charge but it has mass. What is the mass? It is 1.674 into 10 power minus 37. Okay. Next important thing is what is meant by atomic number. Atomic number is represented by the symbol Z. It is the number of protons in the nucleus of an atom. Number of protons in the nucleus of an atom is meant by what? Atomic number, or it is the number of electrons in a neutral atom. What is the total number of protons in the nucleus of an atom, or the number of electrons in a neutral atom is the meaning of what? Atomic number. It denotes the number of protons or electrons in the atom. Next is what? Mass number. Mass number is represented by the symbol A. Mass number is the sum total of neutrons and proton, or we will say it as nucleons. Okay, neutrons plus protons will give you nucleons. Number of nucleons denote mass number, or number of protons and neutrons denote what? Mass number. Next, let's study different atomic model. This is just an introduction, different atomic model. The first atomic model that was developed by Thomson, and he called it as Thomson's model of atom. What the other names of this Thomson model of atom is plum pudding model or raisin pudding. It is also called as what? Plum pudding model, or what? Raisin pudding model, or watermelon model. We will call it as watermelon model. Okay. Next point is what? Atom is spherical in shape. Radius of it is what? Approximately 10 power minus 10 meter. What Thomson said? He said that atom is spherical in shape and the radius of an atom is approximately 10 power minus 10 meter. And also he said that mass of an atom is assumed to be uniformly distributed over the atom. Okay. He won the Nobel Prize. The scientist Thomson, J.J. Thomson, he won the Nobel Prize in 1906 for his theoretical and experimental investigations on conduction of electricity by gas. This is just a GK knowledge. Okay. What all Thomson told? He called it as what? Plum pudding model or raisin pudding model. Okay. Or the watermelon model. He told it as it is a spherical in shape. Atom is spherical in shape and the radius is about 10 power minus 10 meter. And it is a mass of atom is, the mass is uniformly distributed over the atom. These are the conclusions of Thomson's model of atom. Okay. The next model of atom that we are going to study is Rutherford's model of atom. Okay. It is Rutherford's model of atom. Good, fine. Let's try. The next model of atom that we are going to study is Rutherford's model of atom. Rutherford's famous model is what? Alpha particle scattering experiment. Alpha particle scattering experiment. Let us look what he did. He passed alpha particle, high energy alpha particles to a lead plate to a gold foil. Okay, he passed alpha particles. This is the source of alpha particles. He passed high energy alpha particles from a radioactive source. Okay, to the gold foil. The gold foil is surrounded by photographic zinc sulfide screen. Okay. When this alpha particles get deflected from the gold foil, it will touch on the photographic plate. It will touch on the photographic plate and a tiny flash of light will be produced by the alpha particles. A flash of light will be produced. This is the alpha particle scattering experiment conducted by Rutherford and his students. Let us look what were his conclusions. He found that most of the alpha particles pass through the gold foil. These are the atoms. The blue color are the atoms of gold. Okay. Most of them pass through the gold foil without getting undeflected. Okay. Without getting deflected, they all pass through the gold foil. Some of them deflected at small angles, okay, and some of them bounced back. These were some conclusions of alpha particle scattering experiment. These are the conclusions by Rutherford. And he said that the positive charge of the atom was densely concentrated in the extreme small region nucleus. There is only an extremely small region of nucleus. Compared to the atom, there is only small region of nucleus because only some of the rays got deflected. Other all rays passed through it. So he concluded that only small portion is positive in nature. Only a small portion is what? Extremely small region is the nucleus. Okay. The second conclusion was the nucleus is surrounded by electrons that move around the nucleus with a very high speed in circular path called orbits. Okay, the electrons revolve around the nucleus in circular paths called orbits. And the third conclusion is that electrons and nucleus are held together by electrostatic force of attraction. These are the conclusions made by scientist Rutherford by his experiment alpha particle scattering. He said that the radius of the atom is about 10 power minus 10 meter while that of nucleus is only 10 power minus 15. Okay, that much small is the nucleus compared to the atom. Okay. The radius of the atom is what? 10 power minus 10 meter, but that of nucleus is only what? 10 power minus 15. That much small is the nucleus compared to the radius of the atom. The drawbacks of Rutherford's model is that he could not explain the stability of an atom. The next drawback is what? He couldn't explain the electronic structure of the atoms. These are the main drawbacks of Rutherford's model of atom. Next is the developments leading to Bohr model of atom. Okay, developments leading to Bohr model of atom. The main developments that led to the Bohr model of atom are dual nature of the electromagnetic radiation And also second one is the experimental results regarding atomic spectra. That can be explained using what? Quantized energy. That is where quantum comes. Quantized energy. Planck's quantum theory. Okay. Dual nature of electromagnetic radiation and the results regarding atomic spectra. These are the two major important things for the rise of Bohr's model of atom. Okay, next topic that we are going to discuss is electromagnetic waves. Electromagnetic waves. That means what? When a charged particle is kept under acceleration, it shows what both electric, it exhibits or it transmits both electric and magnetic field. When a charged particle, when a charged particle is kept under acceleration, it transmits both electric and magnetic field. Okay, this magnetic field and electric field transmitted are known as electromagnetic waves. The field is transmitted in the form of a wave. Okay. The scientist James Clerk Maxwell, he told that accelerated electric charges generate linked electric and magnetic disturbances that can travel indefinitely through the space. That is, this is the representation of a wave, isn't it? We can represent a wave like this. What is a wave? It is a form of energy that we already know. Wave is a form of energy. This is how a wave transmits. What the scientist told is that for a wave, it has both electric and magnetic field component, and that electric and magnetic field component will be mutually perpendicular to each other to the direction of the wave. Okay, if this is the electric field component and this is the magnetic field component, they both are perpendicular to each other and also will be mutually perpendicular to what? The field, the direction of what? The direction of the wave. This is what the James Clerk Maxwell, the scientist, told. That is, the electric and magnetic components are perpendicular to each other and perpendicular to both the direction of propagation. Next, let's study about the characteristics of a wave. Characteristics that all waves have in common are what? Wavelength, amplitude and frequency. We are going to study about wavelength, amplitude and frequency. These are the characteristics of a wave. What is a wave? It is a form of energy. The maximum disturbance or the height of a wave is called what? Amplitude. The height of a wave is called amplitude. If this is a wave, then this height is called what? Amplitude. This is the distance from the midline of a wave to the top of a crest or to the bottom of a trough. Okay. The distance from the particular point on one wave to the same point on the next wave is called as what? Wavelength. That means distance between this point from the height of particular to this point. That is the distance from a particular point on one wave to the same point on the next is called as what? Wavelength. The unit or wavelength is measured in what? Meters. The unit of wavelength is meters. Wavelength is represented by the symbol lambda. Okay. We use lambda to represent wavelength. It's the distance from a particular point on one wave to the particular point on the other. Okay. The number of waves passing every second is called as what? Frequency. The number of waves passing a point in every second is called what? Frequency. The number of waves passing a point in a wave in every second is called frequency F. Frequency is measured in what? Hertz. Frequency is represented by F, or we can represent it as nu. Nu represents what? Frequency. And the unit, it is measured in what? Hertz. Okay. Or we represent it as Hz. This is the representation of a wave. We can see the distance between these two points are called as wavelength lambda, and also the height is called as what? Amplitude. Okay. Next, the one of the characteristics of a wave is that unlike sound waves or water waves, these electromagnetic waves does not require a medium and it can move in vacuum. They move in vacuum. This it does not require a medium to move. Okay. Electromagnetic waves move in vacuum. It does not require a medium. This represents the electromagnetic spectrum. Look here. This is the representation of an electromagnetic spectrum in the order of increasing frequency. That is from this side to this side. It is represented in frequency. Frequency increases in this order, and as a result what? Wavelength increases in this order. Okay. These are the gamma rays having what? The highest frequency for gamma rays, and then for X-rays, then the UV visible, and then for IR, then for the microwave, then for what? Radio waves. And the least frequency is there for long radio waves. Okay. This is the electromagnetic spectrum and the visible region. This is the visible region that is elaborated and shown here. Okay, VIBGY or color. You should study the order in the increasing frequency or in the increasing wavelength order. Any order you can study the what electromagnetic spectrum order is important. And radio frequency region is in the 10 raised to 16 hertz. Okay. Microwave region. What is this microwave region? Microwave region means the region you all have seen microwave oven, isn't it? We will heat the substances in the microwave. This hertz, 10 power 10 hertz. That is the microwave region. Next is the IR, infrared region. That is 10 power 13 hertz. UV region is for 10 power 16 hertz, and that of visible region is 10 power 15 hertz. Visible region, that is visible to our naked eye, is called visible region, and that is 10 power 15 hertz. Hertz means frequency. Next important point that you should remember is the speed of light. The value of speed of light is 3 into 10 power 8 meter per second. 3 into 10 power 8 meter per second is the speed or the velocity of light, we can say. Approximate value is 2.997925 in 10 power 8. We will approximate it and we will take the value 3 into 10 power 8 meter per second for the calculation. For doing problems, remember this value, the velocity or the speed of the light. We can connect frequency, wavelength. What was frequency? In 1 second, how much waves test that point, isn't it? And what is wavelength? The distance between the 2 points in a wave. And the velocity of light. We can relate frequency, wavelength and velocity of light by the equation C is equal to nu lambda, where nu is the frequency, C is the velocity or the speed of light, and lambda is the what? Wavelength. The equation is C is equal to nu lambda. The other characteristic of a wave is what? Wave number. What is a wave number? It is defined as the number of wavelengths per unit length. The number of wavelengths per unit length is what? Wave number. Its unit is what? Meter inverse, because we know that wave number is represented by nu bar. Okay. Nu is frequency, nu bar is what? Wave number. That is the reciprocal of what? Wavelength. 1 by lambda. That is what? Wave number. Nu bar represents wave number. Okay. Wave number is the reciprocal of what? Wavelength. Commonly used unit is what? Centimeter inverse or meter inverse. We know that for lambda the unit is what? Meter. Then for wave number it will be what? Reciprocal, meter inverse, or we can say it as centimeter inverse is the unit of wave number. Okay students, thank you and have a nice day.